Hello everyone, we are from Gokaraju Rangaraj Institute of Engineering and Technology presenting you a brief explanation on our major project titled as Design and Optimization of Planar Inverted F Antenna for Wireless Communications. I am Rishta and my team members are Gautam Reddy and Hemant. Coming to the contents of the presentation, the contents are introduction, project objectives, proposed methodology, design of the antenna, output, applications, conclusion. And the introduction is the project focuses on enhancing a planar inverted F antenna by integrating a single PN diode for frequency tuning through rigorous electromagnetic simulations and optimization techniques. The goal is to precisely manipulate the diode is biasing to dynamically adjust the antenna's resonant frequencies. The project explores diode placement, biasing voltages, and antenna dimensions to achieve the wide tuning range while maintaining stable radiation and impedance characteristics. Additionally, it investigates the integration of a diode within the antenna structure and develops a control circuit for precise voltage regulations. The antenna dimensions are 44.2 mm and 54.5 mm printed on an FR4 epoxy substrate with a relative dielectric constant of 4.3 and loss tangent of 0.002 and 50 omega coaxial field length. The proposed antenna has two patches connected by a single PN diode. The antenna introduces two resonant frequencies which are under S parameters or return loss of minus 10 decibels, which are of 2.2 GHz and 3.3 in off state and on state of the PN diode, which are applicable to cover LAN and Bluetooth communications. And the main project objectives are the frequency range specification, power amplifier design, wide tuning range, efficiency enhancement, matching network design, low power consumption, and temperature stability. So the proposed methodology is as follows. The design methodology has some of the steps considered to design an antenna, uh, and the process goes like this. The radiating element is known as the antenna, consists of a radiating element, typically a patch or another structure, and a ground plane. And second is the feeding network. There is a feeding mechanism, usually a transmission line or a feed point that connects the antenna to the external circuitry. And the integrating the pin diode. The pin diode is strategically placed within the antenna structure, often in the radiating element or along the transmission line. Its position determines how it affects the electrical properties of the antenna when biased. The operating principle of the antenna is like when the pin diode is unbiased or reverse biased, it acts as a high impedance element. Upon forward biasing the diode by applying a specific voltage, its resistance decreases and capacitance changes. This change in electrical properties affects the antenna's impedance, altering its resonant frequency. By adjusting these bias voltages across a pin diode, the effective electrical length of the antenna can be modified. Changing the effective length of the antenna alters its resonance and consequently shifts its operating frequencies. And the software used in the designing of the antenna is known as CST software. It is one of the most used software to design antennas. It is a high performance 3D EM analysis software package for designing, analyzing and optimizing EM components and systems. The software offers a wide range of customization options that allows users to tailor the software to their specific needs. It supports a wide range of applications from the design of the microwave components to the simulation of complex electromagnetic systems. The proposed methodology of the system antenna design is depicted design of the single band PIFA antenna is shown is in the below figure, in the figure given in the slide with a no diode. So the antenna comprises patch printed on a Rogers R4350B substrate with a dielectric constant of 3.40 and a thickness of 0.762 mm. And the parameters of the design are same as a PIFA with single diode, which are discussed in the further slides. PIFA with a PN diode is also the same structure as we discussed in the before slide, which is PIFA with no diode. The design and the process of design is almost same, as the only difference is the PN diode, which is attached or adjusted between the radiating patch of the PIFA antenna. So the PIFA design incorporates a PN diode to enable dynamic adjustments to the antenna length, therefore allowing for flexible frequency tuning across various frequency bands. In its forward state, like the diode serves as an electric switch between with two distinct states on and off, achieved by biasing the diode in either forward or reverse direction. In the forward bias state, the PN diode behaves like a conventional PN junction diode, permitting current flow in one direction while blocking it in opposite direction. This configuration alters the resonant frequency of the PFA. When the diode is in on state, it can be represented as series combination of a very small resistor of 1 ohm and an inductor of 0.15 nanohenry. The low resistance allows current to flow through the radiating element, leading to a change in the resonant frequency. And in the off state, the equivalent circuit model comprises a parallel combination of higher value resistor of around nearly 10 kilo ohms and a capacitor of 0.25 picofarad, both in series with an inductor of 0.15 nanohenry. This configuration resists current flow, affecting the resonant frequency differently compared to the on state. So the outputs are like, as we can see in the figure, this is a S parameter graph of the PIFA antenna with no diode, representing resonating at the frequency of 3.3 gigahertz and the return loss of minus 10 decibel. The far field pattern and the directivity of the antenna are as given in the slide. And the output of PIFA with the PN diode is as shown in the figure. The green lines indicates the PIFA antenna when it is in on state, and the red line indicates the PIFA antenna when it is in off state. Whenever the PIFA antenna is in with the PN diode in on state, the antenna resonates two frequencies at 2.2 GHz and at the 4.4 GHz. Whenever it is a PN it is in off state, it resonates at only 3.3 GHz, which is almost same as the antenna with which resonates with no diode. And the VSR doubler ratio of the both states are given in the following figures, as we can see, and it indicates the both of the values are less than 2, and the radiation patterns of on state and on state are given with the directivity figures of on and off of the PIFA antenna. There are wide coming to the application, there are wide range of applications which are used in various wireless communication applications due to its compact size, low profile and versatile performance. Some of them can be described as mobile phones, wireless local area networks which are commonly called as WLANs, and IoT devices, global positioning system receivers and variable receivers, devices like smartwatches and fitness trackers. Coming to the conclusion, a comparison between a compact PIFA antenna and a reconfigurable PIFA antenna with a single diode is presented in this presentation. The presented structure functions with a single PN diode that resonates at two different frequency ranges suitable for various wireless device applications. To attain frequency reconfigurability, the introduction of the diode switches proves instrumental. The designed antenna exhibit VSR doubler ratio and return losses well within the acceptable limits. As we can see, the antenna resonates in three different frequency ranges according to the on and off state of the PN diode. This addition introduces a level of system complexity given that modifying the circuit parameters of the PN diode to achieve resonance at different frequencies can impact gain and return losses, requiring careful consideration for optimal performance. And thank you for paying attention for the whole presentation. Thank you.